The fourth lecture video on temperature and heat will discuss more details of heat transfer, including how we can calculate it. In order to calculate heat transfer, first we need to discuss thermal conductivity. Thermal conductivity is the ability of materials to transfer heat by conduction. As most of you probably already know, metals are really good conductors. This is why pots and pans used for cooking are typically metal. Glass and air are poor conductors, which mean they are good insulators. The rate of heat transfer depends on four factors. The first is the thermal conductivity of the substance. The second is the cross-sectional area through which the heat flows. The third is the thickness of the material, and the fourth is the difference in temperature between the two sides of the material. Now that we know a little about thermal conductivity and what the rate of heat transfer depends on, we can look at an equation to calculate the total amount of heat transfer. Q is the total amount of heat transferred in joules or BTUs, depending on the rest of your units. This is equal to K times A times the quantity capital T2 minus capital T1, all divided by L, where K is the thermal conductivity, which can be found in a table, A is the cross-sectional area, T is the total time, capital T2 is the temperature of the hot side, capital T1 is the temperature of the cold side, and L is the thickness of the material. The really tricky thing about this equation is making sure you have correct units for all of your values. Depending on if you use the English or metric units for thermal conductivity, this will dictate what all of your other units need to be. Let's take a look at an example of heat transfer. Find the heat flow in 24 hours through a 48-inch by 48-inch pane of glass, 0.125 inches thick, if the temperature of the inner surface of the glass is 68 degrees Fahrenheit and the outer surface is 12 degrees Fahrenheit. There is quite a bit of information we are given in this problem, so we definitely want to write everything down first, and we want to make sure that all of the units are correct for the equation. First, we know that we have glass, so the thermal conductivity or K value of glass is 0.50 BTUs per foot degree Fahrenheit hours. Next, we know the area of the glass. 48 inches is 4 feet, so we have a pane that is 4.0 feet by 4.0 feet, or 16 square feet of glass. Notice how area needs to be in square feet because part of the unit in thermal conductivity has feet, so the area always needs to be in feet. Next, the time we are looking at is 24 hours. The warm temperature, or T2, is 68 degrees Fahrenheit. The cool side temperature, or T1, is 12 degrees Fahrenheit. Last, the thickness, or L value, is 0.125 inches. However, we need thickness in feet, so we will divide this by 12. This gives us a thickness of 0.0104 feet. In this problem, we are trying to find Q. Now that we have everything written down with correct units, we can go ahead and write down the basic equation. Q equals K times A times T times the quantity T2 minus T1, all divided by L. Next, we can substitute. Be careful on this step since there is a lot we have to write down. Q equals 0.50 BTU per foot degree Fahrenheit hours times 16 square feet times 24 hours times the quantity 68 degrees Fahrenheit minus 12 degrees Fahrenheit, all divided by 0.0104 feet. If we enter this correctly into our calculators, we should get an answer of 1.0 times 10 to the 6th BTUs. If you have ever installed insulation as a home remodeling project, you know that the insulation value of construction material is given as an R value. This indicates the ability of a material to resist the flow of heat in US units or English units. The R value is inversely proportional to thermal conductivity and directly proportional to the thickness. The R value is found by taking L, the thickness, divided by K, the thermal conductivity. The units for the R value are a little odd. They are square feet, degrees Fahrenheit, hours per BTU. However, whenever we are talking about an R value, we just say R whatever the value is instead of using the actual units. Again, the R value will be in US units, so the thermal conductivity will be in BTU per feet degree Fahrenheit hour, and the thickness of the material will be in feet. Let's take a look at an R value calculation. Calculate the R value of 8.0 inches of mineral wool insulation. First, we will write down the data we know. The thickness is 8.0 inches, but thickness needs to be in feet, so this is 2/3 of a foot. K is the thermal conductivity of mineral wool insulation, and this is 0.026 BTU per foot degree Fahrenheit hour. We are trying to find R. The basic equation for R is that R equals L divided by K. Substituting, we have 2/3 of a foot divided by 0.026 BTU per foot degree Fahrenheit hour. This gives us an R value of 25.6 square feet degrees Fahrenheit per BTU per hour, or since those are some really ugly looking units, R 25.6. This concludes our discussion on heat transfer.